I'm gonna come down here with this minus 8x squared minus 25x minus 3. Is that okay, clear?
Yes, yeah.
All right, now this is the harder type of factor. Roughly this has some shape like that. It opens down. This one's gonna be a little bit harder to factor. This one requires you to do this grouping technique where you take the -8 times the -3, which is 24. Find two numbers that multiply to 24, but add to -25. That's -1 and -24. So what you're doing is you're splitting that one apart. Minus 24x, minus 1x minus 3, minus 8x squared, like that. And then you factor out the GCF of the first two. So minus 8x. And then you get an x minus 3 in here, x minus 3 in here. You might have seen this as like a diamond method in a previous course, where you break this apart to get these two, but then we're almost there. You're trying to find the number that goes in the middle here such that when you multiply in, you get back to minus 1x minus 3. Did I make a mistake here? Oh, this should be a plus. That's the issue. Okay. So it ends up being minus 1. The reason it's plus is you're dividing both of these by minus 8x. The reason I didn't go right to the calculator is that you may not, like, you would probably see that this one was -3, but you might not see that the other one was -1/8. So because you're going to set each of these factors equal to 0. And this was the harder one of the two anyway. So I don't know that you would get this, but those are the two critical numbers.
Okay.
So we talked about, then you put them on a number line, -3, -1/8. If it's below the x-axis, and we know it's below because the parabola opens down because the leading coefficient is negative. If it's below the x-axis, that's a negative.
Okay.
Above the x-axis is a positive. Below the x-axis is a negative. And so the minus to plus, the minus to plus here, this ends up being a min. The plus to minus ends up being a max. So all that being said, the way to answer this, you can see that you got the A, B, C, and D there. It has a relative max and a relative min. Let me make this a little larger. So the max is at -1/8 and the min is at -3. To get the actual max and the actual min, you have to put these values back into the original.
Okay.
So what a hassle, but we can do that here. So we're going to put -1/8 in for x and then -3 in for x. So it's -8/3, parentheses, -1/8 cubed, minus 24/2, -1/8 squared, minus 3 times -1/8 plus 15. I'm also going to do this. This could be kind of a nightmare to do.
Especially with the 1/8. A lot of typing.
Wow, that's awful. So I get a pretty awful fraction, which makes me believe this may not be correct.
Okay. Yeah, I got -69/2 for not for -1/8, but for 3.
Okay, let me try for 3. That's the better one. I got -33/2. Maybe I entered it wrong. -8/3.
Oh, I forgot to put negatives on it for some of them.
So the
Okay.
then this number goes up there.
Ooh, okay. Okay, that was right.
Fantastic.
It's not a fun number.
All right, next one here is, so I believe this is when you started scrolling back more towards the beginning. Cost function, revenue function. All right, so the marginal cost is the derivative of cost. So you just have to take the derivative of this 97q plus 91. You treat the q like it's an x, so the derivative is just 97. Is that okay?
Yep, that's easy enough.
All right, the profit function, profit is revenue minus cost. So that's the 97q plus 50q over natural log of q minus 97q plus 91. The reason it's in parentheses is the whole thing is the cost. You're subtracting the whole cost, not just the first term. You'll
Okay.
notice that when you distribute that negative in there, that it cancels with that term will cancel with the 97q. So these cancel out here.
Okay,
So
yeah.
your profit function is just the 50q over the natural log of q minus 91.
Okay.
Please make sure that's correct before we proceed.
Yes, that's right.
Find the profit from one more unit sold when 8 units are sold. The way this reads, and I'm taking a bit of a guess here because I don't remember us doing any of these problems together, so I'm not entirely sure. But it's essentially asking you for to take the derivative of this. So n deriv, you'll want to use x instead of q, and then it's at when x equals 8. So will you try that for us?
Yes.
And if that doesn't work, maybe we can.
Things being weird. It's not letting me. Hold on, sorry. Won't let me get out of the parentheses to do the negative 91. Like when I click the next arrow, it's just taking me to the x equals.
Yeah,
Um, yeah, it won't let me get out of the parentheses still. Like I can't put in negative
okay,
91.
so let me try to just, so the way I would enter this is 50 x slash natural log x close parentheses minus 91.
Yeah,
Will
it just
that
won't let
work?
me after the close parentheses enter anything.
Really? So let's do it in the beginning. Let's put minus 91 plus 50x slash natural log
Okay.
of x.
X divided by. Okay, got 12.481.
Okay, what does it say to round it? Because I don't have anything
Yeah, it just
there.
says 2 decimal places, so 12.48. Oops. Okay, and that was right.
Okay, well, that worked out nicely.
Sweet.
Sorry, I had to get back to where, okay, so we're going, I think, further up. Something about Chris Lynch plans to invest $500 in a money market account. Find the interest rate that is needed for the money to grow to $1,600 in 12 years if the interest is compounded quarterly. Okay. So the formula is that the future amount is the present amount, 1 plus the interest rate divided by n to the n times t power, where n is the number of compounding periods. So in this case, when it's quarterly, quarterly means that n equals 4.
Okay.
So he's trying to get to $1,600. He's starting out with $500. We're trying to figure out the interest rate, but you're dividing it by 4. And he wants to do this over 12 years. So 4 times 12. Now, if this were multiple choice, you would just try the interest rates and round them to you would try the percentages. Let's just say an answer is like 7.2%. You would put in 0.072 for R
Okay.
in your multiple choice. Now, since we got to do this by hand, um, solve this by hand, you divide both sides by 500. Now you undo this power of 48 by raising it to the power of 1 over 48 on both sides. So you have 1 plus, and I'm just switching sides here, r over 4 equals 1,600 over 500 to the power of 1 over 48. When you enter that into the calculator, you may have to do it like this.
Okay.
Okay, but there's a bit more to do. You have to subtract 1 and then multiply by 4. You're not going to have to do this on the exam, so I'm going to just finish off the steps
Okay.
here for you. But this is what goes in the calculator. Subtract 1, but then you multiply everything by 4. All right, so if you want, you can calculate it. I'm going to also calculate it here.
Okay. Do I put all the parentheses in when calculating it?
Yes, yes. I tend to write it the way you'd put it in a calculator. So I get 0.098. And it does say to the nearest
Okay,
percent. This is 9.8%, which rounds to 10%.
okay, perfect. That was right.
All right, so the next one is there another part to that?
No.
Okay. The next one here is one we tried entering 5 years, right at the decimal, and M is the number of compounding periods. Okay, 5 years. So what I think I'm not seeing here is I think it should be written like this. I know you're down to your last guess, attempt, whatever. 1 plus R over M 5M. This will not affect the next part. Does it say quarterly anywhere though in here in this
Um,
first one? reading
No,
it one
it
more
just
time.
says time
Okay.
yearly. Okay, perfect. That was right. And then it asks the required annual interest rate if interest compounded annually is blank.
Okay, so now this is where m equals 1. So this is 3,500 equals 3,000. 1 plus r over 1, 5 times 1, like that. So this is 3,500 equals 3,000. 1 plus r to the power of 5. So this one solves much the same way as that other one. I'll spare you the details here. It's 3,500 over 3,000 to the 1/5 power minus 1. So this will need to be in parentheses, the 1/5.
Okay. Okay, I got 0.03131.
Like that. So maybe 3.1%. What does it say to round to?
2 decimal places.
So 3.13. Try that without the percent.
Okay, that was right. And then required annual interest rate if it's compounded quarterly.
Yeah, so for quarterly, what it does is it changes a couple of things here. I'm gonna just copy and paste here. Quarterly changes this to a 4 and a 4, so this becomes 20. And so this becomes 20 over here, and then you end up multiplying everything by 4.
Is there a way for me to do that on my calculator without rewriting the whole equation?
Yeah, hit second entry, which is under A and S, or enter. It's under enter,
Oh,
lower right. You got to go back to the beginning though and insert the parentheses, or you can put the 4 times on the at the end.
all right, I got 0.09811.
Okay, so this would be 9.81%.
It said that's incorrect.
All right, let me double check here. I'm surprised it's that much higher. But let me try it here on my side. 3,500.
Oh, wait,
Yeah, I've got a different number.
I put in 48 because I forgot to change it.
Since this will be multiple choice, wouldn't take too much stock in any errors in this.
It said that was wrong.
What are you rounding to in this one?
2 decimal places.
Oh, I see. I have a mistake in mine. I missed a 0. Right. Yeah, we're both way off. 3.09%.
All right, that one is correct.
All right, great.
And that's the last part on that one.
All right. We did that one, I think. Yeah, we did that one. All right, so here, this one looks to be closer to the end. So this is the third derivative, which means you have to take a first derivative, which I'll ask you to do just for practice. We'll get to the third after.
So 8x cubed plus 12x squared. I'm running out of room here. Plus 8x plus 3.
All right, really good. So I'll do the second one. All right, and you're just bringing that exponent down each time and multiplying 24x squared, 24x plus 8. So I'll let you do the next one for us, please.
Okay, sorry, I just finished up. All right, so it would be the third would be 48x plus 24.
Good. So that is the answer to the first box.
Okay.
Right. And then for the fourth derivative, this is we don't know, we don't have to worry about why, but they switch to numbers after instead of tick mark.
Okay.
For this one. So the derivative of 48x is just 48.
Easy enough.
That's your second box.
All right, and then that was the last one for that one.
Okay. Give me just a moment. I'll be right back with you. Just need like 10 seconds.
Okay,
Something.
I'll be back as well. I'm getting a call. I will be right back. Hello. Hi. I was just wondering if you have any appointments today by chance at like 4:30 or anything tomorrow. Sorry about that. I'm back.
No problem. Here is the next question. Find the open intervals where the function is concave up or concave down. So concave up, I don't think we've talked about this at all. There's a couple of ways the graph can look. It's generally like this or like this. And you might hear the term like holds water. You also see people sort of holding their hand where the palm is up, raised up, if you can imagine that visual.
Okay.
That's only just helpful to remember. You don't need to do this and
Okay.
practice here. Down is going the other way. This is concave down. This is up. All right. So the problem is trying to help you by giving you what's called the inflection point. An inflection point is where it switches directions. So I'll highlight it here. Everything on the left here is concave down. Everything on the right is concave up. Now there can be more than one inflection point, but in this one, they just have the one. You only care about the X values.
Okay.
So it's like with increasing and decreasing, you only care about the X values. So this one is, it's answer A. It's concave up from 2 to infinity. That's the hold water. 2 because of that X value there. Concave down on minus infinity to 2.
All right, perfect. That was right.
Okay, so you might think, oh, I got it. No big
Oh,
deal.
yeah.
But there's a bit more. Why is it doing that? Stop doing that. So here we go. All right, next question. This time they don't give you the graph and they don't give you the inflection point, which means you
And the
have to
inflection
do
point was 2 for that one, right?
yes, 2 comma,
Yeah.
whatever that is.
Okay.
What's x equals 2?
All right, just make sure. Sorry. Go ahead.
All right. For this one to find where it's concave up or concave down, you have to find the inflection point which comes from the second derivative. So you're gonna have to take 2 derivatives of this. So the first derivative I'll do minus 9x squared plus 10x plus 166. Will you take the second derivative for us, please?
First, negative 18x plus 10.
Set this equal to 0, and you end up getting x equals minus 10 over minus 18, or 5 over 9. Now, it would help to have a picture of the graph, but you can also make a sign chart. So if
Okay.
you wanted to get a picture of the graph, it would look something like in this previous problem here, and you could then just figure out where it was concave up or concave down. Do you
Okay.
think you would graph it, or you could do a sign chart with 5 over 9? What do you think you might do?
Probably graph it just because
Okay,
I'm a
so
lot
why,
more
so
comfortable
why
with
don't
that.
you graph it and tell me whether it looks like this one or it looks like this one, roughly. And if you need help graphing that, let me know. I'm happy to jump in. Now you're graphing the original. Very important. Remember that you're graphing this original up here.
Okay. I think I just need to adjust my window because I can't
Right.
see.
So you can do a zoom standard, which probably won't help, or a zoom fit. Fit is the better one, and it doesn't work perfectly. It tries to, it's like a one size fits all. Doesn't really always work for everything.
Okay. I got kind of this like it's kind of hard to describe it, but it's just going downwards.
Is so that you want a big enough window to see the end behavior. Like you don't actually care what's happening in the middle. You just want to know whether it's, going up and down, or whether it's going down and then up.
Okay. You can't really tell on the left. You can tell on the right that it's going down, but
So
it's only
it
the
ends up being this one right
quadrant.
here,
Okay.
top one. You want to zoom out enough till you can figure that out. Now, once
Okay.
you figure that out, that tells you where it's concave up. It's concave up in this first part, um, and concave down on the other. So there's this first. Sorry, trying to find my cursor. There it is. This is like up, and this next part is down. Like this is the up part, this is the down part.
Okay.
Is that good?
Yes. So
So
it
that,
would
so it's up from minus infinity to 5 over 9, and down from 5 over
find
9 to
so
infinity.
that in okay, perfect. That was right. And then it just asked for the inflection point, so that's 5, 9, right?
Does it want the other value or just the x value?
Oh yeah, it says ordered pair, so
That to get the y value, you have to put that 5 over 9 back into the original up here, which looks like it'll be pretty bad, pretty horrible. Does it say to round or just to give you the fraction?
Not just says to give a fraction or integer.
All right.
-2. Okay, I got 91.25. And then I need to convert it to a fraction, which is,
Yeah, I don't know if your calculator will.
how do I do it against math?
Math enter, and it says 2 frac or F to D or something.
Okay, I got a huge fraction. Yeah, the same as you. Okay, perfect. All right, that's all for that one.
That's we're down to the last question as far as I can tell. So
Yes.
if yours is different, let me know. But this is the last one.
Mm-hmm.
First thing I want you to do is graph this one. We're not going to take a derivative this time. When you graph it, it's the bottom is in parentheses,
Okay,
and
why aren't
it'll
we
either.
graphing it this time?
I'm sorry.
Why aren't we graphing it this time?
No, you are. I want you to graph it. Sorry,
Oh,
we're not going to take a derivative. Tell me which one it looks like though when
okay.
you're done.
It looks like the second one.
Looks like this one here. So the on the right here is concave up, and this is concave down.
Mhm.
So if you get this problem, you have to remember to just graph it, not taking the derivative. Pretty tough quotient rule. So where is it divided? Well, it's divided at this x equals -5. That is the vertical asymptote. So you have to know where that point is, which is just setting the bottom equal to 0.
Okay.
So you can see now that it's concave up from -5 to infinity. It's always the x values, and down -infinity to -5. It would appear in your course they're only choosing one place to break it up.
Okay. Okay, that was right. And then it says find the inflection point.
There are none in this
Boarding
case.
point.
There's
Okay.
no inflection points because part of it's because it's discontinuous. The break is an asymptote.
Okay. Okay, perfect. And that was it for the long practice midterm.
So we have some time left here. Do any of them allow you to give another practice, another version of it, or
Yeah, they all say similar questions that you can
okay?
get.
So that would be my suggestion for how to study is,
Okay.
I mean, if you had infinite time, right, you would just redo the whole thing.
Right.
Um, you want to look for the ones that you should do correctly, look for the easy ones, make sure you know how to do those. Uh, but we have some time left. If you want, we can absolutely go through some more, or I don't know what else there would be. Have you done like the midterm acknowledgement? Like they make you sign a thing,
Yes, I believe so.
and you've got everything else, make sure you got everything else turned in. There's no flags up that, you can't take the midterm. That's another thing to look for.
No, I have everything done. They sent over the materials. I just have to show them the email that my teacher said that I got over an 80 and that I don't have anything flagged. Let me see, I might have, what we could do is I might have a test that I took on my own that, but I'm not positive. Let me take a look. Because that could be good practice. Okay, yeah, I have one that I got a 65 on, but I don't know if we'll be able to finish it in time because we only have 10 minutes. Because we'd have to redo the whole thing.
I mean, if you have time, we can do some. Yeah, I mean, I fully booked. I can't extend the lesson, but
Right,
we can.
yeah, that's
can-
fine. We could just go over some, like you were saying, of
Sure.
the
Yeah. Yep. And maybe just choose the ones you don't know how to do, or, really don't think you, but the practice midterms are pretty good indicator, if it's not in the
Okay.
practice. So whenever you're ready, share your screen, please, and then we'll.
Sounds good. Okay, let me just find one that I think I need, or a section that is good. We can do this. Go over limits again, just because it's been a couple sessions since we. It says I can't, it's been disabled for me to share my screen.
Oh, I'm sorry. Let me make you co-host here. I apologize.
No worries.
All right, there you are. You should be able to share your screen now.
Perfect. All right, so this is the one I chose, and here's a similar one.
Okay, yeah. For this one here, I can almost just talk you through it because it's top heavy and not top heavy. It's the same heaviness in the top and the bottom, the same degree. It's just the ratio of the leading coefficients. So the 8 in front of the x squared, the 5 in front of the x squared, it's 8/5.
Okay, and that's because they're the same heaviness at
Yes.
the bottom.
Yes.
Okay. Long one. This one I get.
This is a classic test question. I'd redo this one you're looking
Okay.
at. So go, is it the same?
Um,
It
I'm
looks
not
the
sure.
same. It looks really similar to when you did. Okay, go to where -3 is on the x axis. And then from the left, so so imagine you're on the curve there to the left. Move your cursor left and going to the right now. So you're on the curve though, but you're moving kind of down, but you're moving right. What is the y value? Keep going to the right, right, keep going right there. What's the y? Oh, too far, too far. What's the y value there?
-1.
Yes. Yeah. So that's what it's looking for in that first box.
Okay.
It's not the actual output.
Okay.
-1 is the same thing. So what you're trying to decide is from the left and from the right. Those are that have the same value. So that's from the left where your cursor is. And if you go down there, that's from the right. Are those the same?
Yes.
They are, yeah. So no, no, sorry. They're not the same. The y values are different. Sorry, I misunderstood what you're saying.
Okay.
The y values are different. One has a y value of 2, the other one has a y value of 0. They are different.
Okay. So what would I enter?
The limit does not exist. They
Limit.
approach
Okay.
different
Thank you.
things.
Okay. Because they're not. Okay. Okay. We can do one of these again just because it's been a second.
Okay. So whenever you see instantaneous velocity or rate of change and a value, you want to use n deriv.
Okay.
N deriv. So you're going to use n deriv. You're going to use x instead of t. You can use that t value of 3 or x value of 3.
Okay. I got 27.
Okay.
The derivatives are probably where I'm most confident at.
Okay. So this is where it's not differentiable is where the bottom equals 0.
Okay, so just -2.
Yes.
Easy enough. It's like I get how to do these. It's just hard because there's a lot of different ones that I'm afraid I'm not going to be able to remember how to do the different ones. We can practice one of these because I know them all.
Do you remember anything at all about the product rule here?
Is that where you do G and F?
Yes, yes. So just, we can do this in real time. So in that box there, type in parentheses, then that first one, the 4x squared plus 5. Close parentheses. And then tell me, what is the derivative of the next one, 4x minus 3? What's the derivative of the next
Just
parenthesis?
4.
Just 4. So put that in parentheses. Plus, now write the second one, the 4x minus 3 in parentheses. And then to the right of it in parentheses, determine the derivative of the first one, the 4x squared plus 5.
So it's just 8x.
Yes.
All right. And then I can keep it like that.
For this, for sure. For multiple choice, it'll be, we'll see.
Yeah. Okay.
This one's a little harder to do, but we can certainly do one. Okay, so the derivative will make a big fraction bar for us first. So you take the bottom, whatever the bottom is, which is, and put it in parentheses, and put it in the numerator, yeah, x minus 9, times the derivative of the top. So in parentheses, though, what's the derivative of the top?
Just 2x.
Good, close parentheses, minus the top, which is squared plus 3 in parentheses, times the derivative of the bottom.
Would it just be 1?
Yes. And then on the bottom is the bottom squared.
Just the bottom like this.
Yep, squared.
Right.
And we don't have to use the whole time if you don't want to. I'm happy to go, of course, but if you're, it's totally up to you. We can keep doing this
Yeah.
for another 5 minutes.
I feel like I just need to like rework some of these and make sure I can do them off my
Definitely
mind.
recommend that. Um,
Because it's
okay,
like I know all of this.
right, right. Um, yeah, I mean, try to use your calculator as much as you can. The
Okay.
good night's sleep, all that stuff usually helps as well.
Okay. And hopefully it's multiple choice.
Yes. All right. If you're okay, we can definitely stop there for today.
All
Are
right.
you
So
okay?